So now I have my Cloud66 account. I logged into my account, and I'm just going to go ahead and try Skycap and create a new Skycap application. Let's give our application a name. And here we'll add the services that make up the app. You can add them under advanced in a YAML file with more flexibility and more power. But here, just to have a simple demo, we can simply go ahead and add services. My first service, let's call it web. I can pull the service, the source code for this service from either a Git repository, or if I have a CI pipeline that builds it into a Docker image for me, or I want to use a Docker image that's off the shelf from Docker Hub or somewhere else, I can choose to do that as well. So my source code lives in GitHub. It's a public repository, and I'm just going to pull that over, put it here. I can choose the branch that my code lives in, and just click Next. Okay, so now I've built my app. The structure of the app is built. The first thing we can do is to take a snapshot. Now, snapshot is your code for all of your services. Here we have one, but if you have more in many applications, that's going to be the case. We're going to pull down the snapshot. Will pull down the source code, and we'll build this source code into an image based on your own Docker file. And we also support build cascades, so you can build one step and then the next one, as well as taking a snapshot of any of your pre-built images. Remember when you could pull in any image that you wanted, even if it wasn't built by Skycap? A snapshot will not only build the source code for all the services that come from a Git repository, but it also builds retags any of the Docker images that you might have anywhere. And brings everything into one single session or a single snapshot. So you have like a snapshot of your application at one point in time. So let's go ahead and take a snapshot. What's happening now is Skycap is putting the source code down and it's building it on a set of servers that we call build grid. And you can follow the build, which is exactly just a normal Docker build, optimized for caching and performance, with an aim to finish the build under 10 minutes. So as you can see, the output is available on the web. You can just follow this. And Skycap comes with a private Docker repository as well. So once the build's done, it gets pushed into this repository and is available for you to use. Okay, now the taking snapshot is finished. You're ready to go, and we can now start thinking about how we're going to deploy this application. So if I set up deployment, I have two options. One is to deploy the application with Maestro, which builds the Kubernetes cluster for you and deploys it. So all you need to do is just to connect it to your cloud provider, and you're off to deploy the application. And the second one is deploying with formations. Now, in this case, I would like to use the formations because I already have a Kubernetes cluster. In this case, it's a Minikube local application, but a Minikube local cluster, but I'm going to use formations to deploy to that. Now, before we go ahead and build the formation, let me just tell you a little bit about what a formation is and what we call a formation. So formation is like any deployment of an application that lives anywhere on a Kubernetes cluster. You can have multiple formations of the same application on the same cluster if you want to have different deployments of application. You can think of it as a superset for environments. If you had production and staging and test and development as your environments for your applications, now you can have multiple productions, multiple stagings, each one being a formation. Okay, so now we're going to create a formation. I'm just going to call it my local formation, and here I can pull down the stencil templates, which are like Kubernetes configuration file templates that I have made earlier. They are prepared for me, and I can just pull them down, but there's nothing to stop you from putting your own Kubernetes configurations that you want or uploading it into a stencil template library. Think of the stencil library as a stencil template as a library that holds your stencils all together so you can reuse them over and over again. And we'll get back to this a bit later about how to put one of these together. But for now, I'm just going to use my demo library. Now that I have my formation, I can create the stencils. Each stencil is a YAML file, and that YAML file will be rendered into a fully executable Kubernetes configuration file. For this demo, I'm going to use a single file deployment. So this all-in-one YAML is a file that I have created in my stencil template library, and it combines everything I need to deploy my Kubernetes application. The first thing it does, it creates a namespace for my Kubernetes cluster. And if you're familiar with Kubernetes, you'll recognize this as a normal native Kubernetes configuration file with some placeholders. The name of the formation, for example, comes from the name of the stencil, comes from the name of the formation. And I would like to see any assets that deployed onto my Kubernetes cluster having proper and correct annotations so I can trace them back. That's why I added these parts. There's nothing stopping you from changing this to a fixed value if you want to, or taking any of these out if you don't like them. This is more for me to make sure that any application that I deploy conforms with a certain best practices that I would like to see in my Kubernetes cluster. So that's the namespace. The second part is a secret that we put in there, that I've put in my template. And all it does, it just makes sure that my cluster has the access credentials for the Docker repository or Docker registry that I have my images in. This could be the Docker registry that is provided by Skycap, which you can get the credentials with this just simple single placeholder, and it will automatically populate it for you. Or if you want to use another Docker registry, you can use that by adding it to your account and referring to it here, which will then render it into a Kubernetes-friendly credentials. The next section that I have here is a Kubernetes deployment. Again, if you're familiar with Kubernetes deployments, you will recognize this as a normal deployment. There's nothing specific or special about this. One thing that I would like to have is all my deployments, I would like to have them end with a -DEP, just to make sure that they conform with some best practices that I have in place. But again, you can change this to anything you want. This file, you don't need to edit necessarily on the web if you don't like it. All these files are backed by a Git repository that's provided by Skycap too. You can pull them down and edit it in your favorite text editor, and then commit them back into Skycap for use and version control. Now, this part is the part that I would like to spend some time going through. So, as you know, with a Kubernetes deployment, you define the deployment, which turns into a pod when it runs, and then I'm going to have the containers that I have inside of that pod. So first thing is the name of the pod, or this service, or this container in this specific case, that comes from the name of the service. And if you remember, the name of the service here, which is lists all my services, is web, so this will be rendered into the name web. And also I want to see where to get the image for that. And as you can imagine, the stencils placeholders have the helpers for you to just automatically generate this file. The name of the image is constructed from the name of your repository, which is automatically pre-populated, as well as the name of the name part of the repository, which is the name of your image, and then the tag, which depends on every snapshot. It changes with every snapshot that you take. So then you don't need to worry about going back to your configuration files and upgrading and updating the tag every time. On the port side, I don't know what my port is going to be when I create the template, so I'll put a require placeholder there for me to so I remember to replace the port. I believe this application serves on port 5000, so I'll just do that. And I know that my Docker file has a command inside of it, so I don't need to specify the command for the pod. Image port request, again, just provides the pull secret, provides the secrets to the Docker registry for this image. Next section is a service. Again, the same things, and the only difference here is that I need to have the external port, that's just service on port 80, and the internal target port is, as we saw, 5000. Everything else looks good. I'm just going to commit that into my repository. I can tag everything I want as well. So let's just proceed with committing back to the Git repository. Okay, so now I have my information and I have a single stencil in there. And let's see how we can turn that into a configuration file that I can just apply to my Kubernetes cluster. I click on render formation. It shows me that I should click on this one. And there we go. So now you see that I have the entire configuration file available. And all I need to do is to apply to my Kubernetes cluster. Now, there are options here that I have. I can download this file, or if there were multiple files, I could just select them and download them as a tarball. But better still, I can just use Cloud 66's command line tool to generate it on my command line without having to download these. It means that I can then put this command into my automatic post-commit Git hook, Git webhook, that then automatically deploys to a formation every time a code change happens. Let's go to a terminal. So my Kubernetes cluster is a empty one. There's nothing there. Okay, so now we see here that we have the entire rendered configuration file in command line, which is identical to the one that we had. So naturally, what we can do is we can just pipe this to my kubectl. And let's see. Well, there we go. Now we have a local namespace with a pod running in it. Let's have a look at our services. That's my service. Now, because I'm running this on Minikube, obviously I need to use Minikube to get to that service. So for that, I'm just going to use Minikube to get to the port. And there we go. So now my application is running in my Minikube Kubernetes cluster locally on my machine using Skycap. In the next video, I'll show you how to break that single configuration file into multiple ones for better practices and for better manageability.